Alrighty, hey everybody. This chair low. I think this chair is lower than usual. I feel like I don't know. Maybe my home office chair is in like a different spot or something. Alright, so I did post all those quizzes for you. Again, apologies for not having them sooner. They're all shorter, but the questions are a little bit more like explain things rather than the true-false style. As we start moving into this, like what's the performance of things or why does the performance matter? That sort of questions more likely. So, open them up, look at them. There's no time limit on them aside from the due date. So if you're not sure about them, ask me. I know it's been a little while since we covered those topics. So happy to at least get you pointed in the right direction if you're not sure about any of them. And because I wrote them all, if they're awkwardly written, just let me know. Like if you're not sure what it's asking, just ask. So I can work on that for you. And then hopefully over this weekend I can get that Trek Wars project graded for you. Last weekend was pretty much shot with my daughter, so that she's doing a lot better finally though. Like I think today was the first normal day. Yesterday was getting there, but we're getting there. So we got to finish out stacks, queues, and Deques today. The Deque is just essentially like a hybrid. So again, these are specialty data structures that if we have a problem that fits this particular approach, it's handy to use because it's very performant. Now, as you saw with like the stack, we're just using a list behind the scenes. So nothing would stop you from just using a list and adding and removing stuff off the end of it. There's no problem there. But what you can do is if you're exposing your data to someone else to use, and they shouldn't go access stuff out of the middle, you can give them a stack. So you can expose just that stack class to them, and then they can go interact with whatever you have in your class, and the only thing they can get at then is that top value in the stack. Because if you just give them a list and say, hey, treat it like a stack, maybe they'll do it, but maybe they'll start pulling stuff out from the bottom and kind of messing with what should be happening behind the scenes. So yeah, it's all about, if it fits the model, great. If it doesn't, then fine. We've got other data structures, but they're very efficient for certain types of things. And then we want to look at resizing our queue to be smaller with this circular queue, right? We only ever resize bigger. So we can resize smaller if we cared to. That was kind of the idea here. We want to see as we're removing stuff, maybe at some point we want to resize smaller. So if I add 1,000 things and then I take out 900 of them, I don't need to keep those 900 memory locations to store stuff. It just would be oversized if I'm only ever adding and subtracting a couple more at a time. So again, it kind of depends on what we're doing with the data, how we're interacting with it. So let's look at resizing bigger or smaller here. All right, so since resize is a helper method here, we can go and figure out if we should get bigger or if we should get smaller. Right, we could do that pretty easily here. Like we could do a quick check. So we decided whether or not we needed to resize when we were adding items. We said, hey, if our back hit the front, we should resize. Right? So in resize, we can check, hey, did the back hit the front? Or are we oversized? And then we can kind of push off that logic. Or we could add another method for resize smaller. Pretty much the loops are going to be about the same. They'll be a little bit different because when we get smaller, we don't want to go copy everything out of the old list into the new list. We only want to copy from the front index to the back index and possibly wrap around. Right? So we don't, like going to the length of data, it's possible we would copy too much here. So if like the front index was 7 and the back index was 10 and we had a size 100, we only want to copy the first couple here that we actually have in the queue, not all that extra stuff that we've wrapped around since resized. So the logic needs to be a little bit smarter about that. For the resizing bigger, doesn't matter too much. If we copy a bunch of empty things, we copied a bunch of empty things. It's not really going to hurt anything there. It might be slightly faster, if we don't copy empty things, like if we were smarter, hey, if the length is, or if the back index, where's my back index? Right, if we just went to either the smaller of back index, we couldn't even do smaller. So if the back index was greater than the front, then we could go front to back. But if the back index is less than the front, we have to copy to the end, and then we would copy not to the front again, but just to the back. So this might be a little smarter here. We just avoided having to do all those checks. We just said, we'll just copy everything from front to back because we know we have the room. So let's just add a resize smaller. We'll do it separate here because I think the logic will be just a little bit different. So this will be resize smaller here. And so we're going to say, okay, let's make a new data. We want the size of divided by 2. And I'm going to do the floored division here to make sure it's an integer value, right? Just in case somehow, I mean, our length shouldn't show up like that because we should be 10 and doubling every time. But who knows, just in case. It's not going to hurt anything to do the floored division here. We're going to start at 0 of the new one. So we're going to go, now we actually have to do that check and see, well, how far do we need to go? So we need to see if the self.back index is greater than the self.front index. That's the easy one. If it is, great, we can just do this loop going from front to back. Back index, assigning it, updating the index each time. Right? That's the easy case. We just go from front to back, and that back index then should always be what, that last value, right? So after we add an item, our back index goes up 1. So when we add something, it was 0. Now back index will be 1, so we don't need to copy index 1. So the range is good that it doesn't include the value of back index. Right, so we're going to do that many items here from front to back. If that's not the case, then, right, then we need to copy from the start to the back, then from the start to the back. Right? So from the front index to the length, to copy everything to the end. And we know we wrapped around because back index is not greater than the front index. So we wrapped around the end of the queue, we hit that circle, then we're going to go back from the beginning of our storage up to the back index and copy those values out. So that wasn't too bad. Right? This was the easy case, this was the hard, we had to go wrap around case. Not too terrible though. We could do it a little smarter if we wanted to be more clever. I'm not too concerned. This works out relatively well. But you want to look at the more clever way? So we have the modulus operator. So we can say for index in range, we want to go, now this is the length of self. And this is going to be how many items we currently have, right? Because our length already does that arithmetic for us. Our length says, okay, well, what is it here? How many items are in this collection, in this queue? Right, so it's going to be index 0 up to the length here. So then my new data at the index, right, can equal a value. So that will be in the new data array. That'll start at 0, go up to the current length of how many items I have. This is everything I need to copy. Right, and what do we need to assign it? Well, we need to assign it the value of self.front index plus the index. All of that, then, we can do modulus by the length of self data. Right, so if I take, hey, where my front is plus my current index. So if front is 7, my first value here is going to go at index 0 in the new array, 7 plus 0, modulus 10. Okay, grab it out of 7. Index goes up by 1. Now grab it out of 8, grab it out of 9, grab it out of 10. Well, there is no 10, but 10 mod 10 puts me back to 0. So I'm sorry, this is self-data, self.data at the index of this. Sorry, that's why you're looking at me funny. So out of the current data storage, grab the value at this index here. Right? And all of that then negates all of this because we're doing the modulus, and the modulus will wrap around for us. Right? When I hit 10, when I hit my max, modulus puts it back to 0. And we're just doing it for as many items as I have. So that's actually the more clever way than all of this, right? That's actually a much better loop. 2 lines instead of all of this, right? And we don't even actually, yeah, even all of that. So let me comment that out. Code, comment, control slash, that's right. And really this same loop, right, works with up here too. It would be the exact same loop from front to the end, copying over. Right? We could do all that. Now the only thing that's missing now is upset about this new index here. Right? Well, the new index, where is the new back? Well, it's going to be whatever the length used to be. So I need to store length before I change self data here. So I do need to track the old length or old size, right? Or number of items or something. I don't know. What do we want to call it? Number of items is the length of self. And then we can set the back index to the length of self of the old length. So if I had 7 items starting at 7, right, I would be at 7, 8, 9, 3 items, wrap around 0, 1, 2, 3. And I'd have that gap in the middle of 4, 5, and 6. Right, so we could do it this route, and this works out. Does this make more sense than this loop here? Again, it's going to do the exact same thing. So whatever makes more sense is fine in the code. Right? It's not even really any more efficient or anything. We're doing the exact same thing regardless. We just happen to be using modulus here to do the wrapping for us. So we say we don't care if with this front plus index goes over because we're taking the modulus. Right. Same idea here. You can do a modulus trick, but we can just check a quick. So an equals comparison is faster than saying, hey, the front index equals front index mod the length, because you don't want to do this every time. So you're ever so slightly faster to do a quick comparison rather than to do the modulus and reassign. Because behind the scenes, it can compare 2 integers really quick. That's a really quick operation, rather than actually doing some arithmetic every time. That might be a waste. So we got some options. So how do we know when we need to resize smaller? Well, that's when we're dequeuing items, right? We should say, hey, you know, we always want to leave some extra space. So if I say, if my internal length is double what I have, that's normal, right? Because every time we resize, we are double the size of what we have. So double is normal. So we should say if we're some factor less than half, then we know we need to resize, and maybe a quarter. So if we get down to a quarter of the total capacity and we resize down to half, the new capacity is now half of our values are taken out of the double the storage, right? So I think the 1/4 is the better factor here. It puts us in the same location as if we're growing, we have double the space. And again, we might start using some of that space, and that's fine. That's what we're supposed to be doing, and we could grow again if we need to. But that's going to keep that internal storage array from just growing, and if we take everything out of it, it'll shrink itself back down as we go. It's more memory efficient to do it that way. So we can check. We can say, hey, if the length of self is less than the length of self data divided by 4, self dot, there we go, there's a dot. So if we're at a factor of a quarter size, now we'll go self dot resize smaller. This will now change our amount of items to capacity back to 50%. Right, so then we can go take out another bunch of values until we have to shrink again. Or we can add some more values and we'll have space to grow. Right? Right, should we make sure that works? So if we add a bunch of values, take a bunch of values out, add a bunch of values, take a bunch of values out, we want to make sure that we don't get things out of order. So let's go, we'll put 100 in, and then we took out, so we'd have to take out like 80 of them or so, probably like around 75, maybe 76. I don't remember when it's actually going to hit exactly the quarter, so let's just take out 80. it should shrink at that point, right? And let's go add a bunch more values then. And it's going to have to resize because it'll shrink from, so it's going to go from 10 to 20, 20 to 40, 40 to 80, 80 to 160. We'll have 100 out of the 160 filled. So a quarter of 160 is actually 40. So it should, once we have 40 values left, it should resize to have 40 out of 80. Right? It should go down in half again. So if we take out, so we probably only need to take out like 60 something to see if it resizes here. Well, let's just do like 65 maybe. And then we'll add in a bunch more values. So we'll go from size of 80. When we add in another 100, we're definitely going to have to increase again. And then we're going to go pull them all out. Now what we want to avoid though, and this actually is fine, but if the length of our self here is 0, and the length of self data, so we should never resize, right? Like 0 is always going to be less than this internal storage here, but at most, so a quarter then of something, right? Is this, if we're at 0, are we just going to resize every time? I think we want to avoid that. Right? We want to stay at like some capacity, at least. Right? So if we're at, maybe it's say the length of self is less than, we want it to be more than a value. So how about we say more than 10 here. So if it's more than 10, but less than a quarter, we should resize. Because this way we're not going to get smaller than 10. Because as we start pulling out more values, I don't want to shrink from 10 to 5, and then, well, okay, well, 0 is still less than that, go 5 to 2 or 3. If we floor division down to 2, it's probably a little excessive. So this will just make sure we don't get any smaller than 10. Comes the minimum. Minimum size. Minimum size? And now, again, this is a little bit ugly to just have like a 10 in here and a 10 over here. So we probably, what we should do then is have some sort of value, like a name to this, right? If you just have some number in your code and it doesn't have a name, when we go back and look at it at the end, like, well, why do we have 10 here? What does that even mean? What does 10 represent? And why do we have 10 here? What does that represent? We can put a name to it. So I can have a minimum size is 10 as like a constant value. So I need, that's circular queue dot minimum size. Right, so it's defined at the class level. So it's defined once for the entire class. Not every instance of queue has its own minimum size. Right, and then we can use that value in here then to, where did that go? Right here, right? We can check, hey, if we're greater than the minimum size and less than a quarter, then we'll go resize smaller. Right? So if length becomes 0, if we have no items left, we're not greater than the minimum size, nothing's going to happen. Right? Only if it falls between 10 and a quarter of the length of the internal data storage. It's a little weird. You got to puzzle through it. And I've done this year after year after year after year. So if I'm talking about it too fast, please let me know. I don't want to make any assumptions of what's going to make sense. Let me zoom that in some more too. That's kind of tiny on the my goodness, the stream. I have words. I have no words. Okay, I think that's viewable. Yeah. Yeah, if you can't ever see it, let me know. Does that look okay? All right, so we want to test it out. So this should work. And then just for fun here, we could run it in debug mode. I put a breakpoint in here so that when we get to resize smaller, the code will stop. I just want to make sure that we actually are calling resize smaller here. The other things you could do, that they call it poor man's debugging, is you could just put print commands in here, and like when it runs, do you see something print out? Nothing wrong with that, but the debugger's right, the proper tool for that sort of thing. So I'll run in the debug mode and give it a shot. Make sure we do resize smaller. And look at that, we're getting smaller here. So I can look at self. So self is my circular queue. It has data right? The back index is 100, right? The front index is 61. So we have a bunch of nuns in here, right? So up to 61 now is the front, right? We've got the value here, we've got the back. So we're about to resize smaller. Okay, let's see if it works. So I'm going to, let me just like put a breakpoint down here. I don't want to, do you want to watch this loop happen, or are you okay? So if you hit continue, it's going to run to the next breakpoint. Nope, sorry, that was the wrong button here. This one here, the continue button, resume here. That's going to break when it gets to, we get to here. No, we didn't get there yet. Where are we here? Are we at the same place? Resume. Uh-oh. We got an exception. Type error, unsupported operand types for list and int. Order of operations bit me here. I have none times the length of self data divided by 2. How do you take a list and divide by 2? Oops. Need some parentheses here. Thank you, dear Aunt Sally. Try that one more time. Okay, so we're about to resize. We'll continue. There we go. So now we're about to set data to the new data. So new data, right, starts at 0, has 61, goes up to 99, and then is of size 80, right, because we had more than 40. Oh no, we went half. So we were at 160, so half of that would be 80, right? So we're sized 80 here. Okay, looking okay so far. So let's continue again. Right, we're going to resize again, right? We're pulling out more values. Is that what we're doing? So now our front index is 96. We're down to 115, right? This is in DQ here, line 131, from main, line 203. So as long as we're not empty, so we're going to resize down and down and down until we hit size 10. Or actually, no, we won't even resize to 10, will we? Because 10 is never less than 10. So when we're at 20 items, and the length is, oh, so if we're at something less than 20, if our length is 80, we'll resize to 40. But once we're at 40, a quarter of 40 is 10. You'll never have something less than, more than 10 and less than 10 at the same time. So our minimum size is actually a little bit messed up here, right? Because we're looking at the quarter of this one. Let's just keep going. Let's see. Keep going. Keep going. Keep going. There, and then our output here, we should get, yep, all the numbers should be in order, right, from 1 to 200. And we can give it a quick little look. Again, a unit test would be better for this sort of thing, when we're just eyeballing it right now, as we kind of explore. We could write unit tests after if we wanted. That seems to be okay. So we probably would have caught, right, if we actually did some unit tests and said, hey, what was the size or the length of self-data to actually, like, is it doing what we expect it to do? Did it resize down to 10? We would find out pretty quick it didn't resize down to 10, right? Because when our length hits 40, 40 divided by 4 is 10, so we've got a problem here, right? So we need to fix that. So what could we do instead? Could we take, what would stop it from resizing lower than that? So we did, what if we did the length times 4 instead of dividing by 4 here? What if we said 4 times what we currently have is less than the length? Right, so then when my length is 5, if I have 5 items left, 5 times 4 would be 20. 20 would be less than 40. 40 would resize. When I have 4 items left, I'd be 16. 16 would be less than 20. That would resize down to 10, right? But then I'm going to be sandwiched here. So I think moving that operator here, I think we'll do more what we expect. Let's try it and see, right? So now we can when we're done, just for fun, you're not supposed to, but you can do this, right? We can look at the q dot data. We can print the length of it when we're done, right? So just give it a regular run. Again, Python lets you do it. You're not supposed to, but we're just kind of having some fun experimenting here. the length is 10. So that seemed to work. So this is the sort of thing we could test in a unit test, that we're resizing properly like we'd expect. So now we've done better. That part makes sense? So we've fixed our queue then, so it will resize itself. All that works so far. So let me go commit that to GitHub. We're getting there. Let's do 2001. All right, so this was our resizing smaller circular queue. And we'll commit and push that one. All right, so now we wanted the deck. It looks like DQ. I don't understand. I don't come up with these things here. And it's essentially a hybrid of a stack and a queue. So you can add to the front or add to the back. You can take from the front or take from the back. So you get to do both things. So with a stack, you were only ever adding to the top, but you said, hey, if you like lay it down, it's just the end of that list. You're only ever adding and subtracting from it. In a queue, we were only ever adding to the front and we were only ever taking from the front, but adding to the back. So we're adding that feature where you can now add to the front here of the list. So it's essentially the same thing here. Well, let's just take all of it. Why not? I'm going to feel a little bad. We have some repeated code. There's some chances to do some like fun inheritance sort of things in here, but we're not going to bother. Is that okay? I feel like that just makes it even harder to follow. I feel like, hey, we could be a circular queue, but then we can go add some more behavior to it. Okay. All right, as long as you're okay with that. So what we want to do then, we have a front. We'll get the front. We're going to add a back that will give you the back value. So again, check this here. If not, we can return the back index -1. Because remember, back index is the next location. So it's always one more than what we have. So back index -1 here. Now the problem is, what if back index is 0? Right? What if we like filled it up so we had 10 out of 10 items, or we got to 10, so maybe because we didn't want room to like recycle around before we grew again. So if we like added a couple items, took a couple out, added all the way up to 10, and then the back circled back to 0. 0 minus 1 actually works in Python because Python lists are ridiculously cool. You can give it a negative index, and that's items from the back. Python lists are fantastic. So we don't even have to worry about this. Rock. -1 is the last item. I think that works, right? We can do that, can't we? All right, now I'm doubting myself now. I know you can slice. You should be able to do -1. We can do -1. Okay. I was going to try it real quick, but pretty sure that works. Okay, so that's back, right? Front is still front. Now we have NQ and we have DQ. So really it's, this is add back is what this one is, right? We're adding to the back here. And this is remove front, right? Adding to the back, removing from the front, okay? So we need a add to front method here. So we're going to define add front, given self and an item. Now we're going to do pretty much the same things here, except we have to check. So we know we should always have space, right? If we ever hit where the back and the front match, we'll resize automatically. So we're never going to have those being equal. So we know there's always going to be front -1. So I'm going to say self.frontIndex -1 equals the item. Or I could just do this. This might be a little faster here. We'll say, hey, front index minus equals 1. Set the front index to the item. Now the front index needs to change, right? So if the self.front index now is equal to -1, we need to move, right? Because we took 1 away we can set it here, but we can't leave it as -1. It'll work for assignments, right? But it's not going to work for all the other arithmetic and all the other things we use front for. So if we hit -1, we need to reset front index then, equal to, well, what is the actual front? It's going to be the length of self minus 1. And if we hit -1, go back to the last actual index. Remember, length is not a valid index, but length -1 is the last index in there. Right? And then if they match, resize. Oh, wait, no, front index. My goodness, did I do the wrong? Front index. So front index -1, set the new front. If we hit -1, that was okay for assigning, but now reset it. And then if the back matches the front, resize. So it should add to the front of the queue, right? And we should kind of sketch it out, right? We've got our fun tools. We can sketch it out, draw some pictures. It's always worth making sure your ideas work on paper, right? There's this kind of design process. Make sure it checks out, because it's really easy to make mistakes, right? So again, we had this little list here. We added a bunch of items, so we'll add like 0, 1, 2, 3, and we've got extra space. So that's 4, 5, 6, 7, 8, 9, 10, right? So then maybe we take out the 0, we take out the 1, right? So this is front and this is back, right? So if we add to front index -1, we'll add something here. Let's add 27. Sure, now we have a new front. Let's add another item to front. Okay, let's add 39. 39, this is the new front. Okay, let's add another front. Okay, well, we're going to wrap around now, so we're going to take up this space. Let's add 42. Front is now over here. We're okay so far? We could add to the back again if we wanted. We could add to the front. Now we got lots of options here. So I think that checks out. So let's add front. We can add back. We can remove front. How about removing the back? Let's remove from the back. So this is remove from back. Oh, that's all tabbed in too far. So if we're empty, again, no good. Otherwise, we'll take, why don't we take back index down by 1 now? Back index -1, and then I can just use back index everywhere, right? Without having to do that arithmetic. And then I want to set that to none. So let's grab the item, set it to none. Again, one of the reasons we kind of breezed over this a little bit in chapter 2, this main idea of object-oriented programming. If you have a variable pointed at something, like we're referencing some value in memory, Python won't garbage collect it. It'll say, oh, something's looking at this, I can't go free up this memory. So if we don't clear up our internal storage here, then we are still referencing that value in memory somewhere. It can't go get freed up. Because I don't know what they're going to do with it, but maybe they're going to use it once and then be done with it, and it would expect it to get garbage collected and freed up in memory, that sort of thing. So just be a little careful with those. And then so if we're removing from the back, then our front index doesn't change. The back index has to change here. So the back index, if it equals, so if we wrapped around from back, we could have been from 0 currently to -1. So if it equals -1, let's reset back index to length of self data -1, right? Just like we did here. If we got too far, length of self -1. Oh no, we can't do that. We can't do length of self because front index is wrong currently. So we need the length of self data, right? Because length actually uses this front index. So if the front index is -1, it'll probably do some weird things. It might work. What does our arithmetic do? It says if back is less than front, length of self minus the front plus the back. So if front was -1, it would add 1 to length and then add the back index. If back is less than front, but back would never be less than front, so we just do back minus the front. So if front was -1, we would add 1. I don't know, I'm confused right now. I think we just avoid that problem. It might work, actually. It might, but feels like a headache. All right, so removing from front was fine. removing from the back. So if the back index then, if we took the back thing and it was 0, right, and we said, okay, let's subtract 1, circle back around, take that one, now we're at -1, reset yourself to that last value. And then resize if we need to. Okay, so that should work now. So we can get the front, we can get the back, you can add to the front, you can add to the back, you can take from the front, you can take from the back. And we should test it. Right? Oh, we got to rename it here too. We didn't rename it. This is now our deck. DQ. Looks like DQ, but there's not the extra UE. I don't know. These are silent letters. You ever see this thing, the word Q here? Is it just the letter Q and then UE? UE is silent?
I actually saw something about that, how it was like we couldn't do that because then UE would be silent in the other words. And that, you know, we all know how the English language, all the rules only work for like 5 words.
Yeah. So, well, what is silent? So usually if there's an E at the end, the E is silent and then the vowel makes its name. So the hard vowel sound. So this would be Q, like this. But we add another UE, and the whole UE, or do we just pronounce Q, and we have 2 U's going on now? I don't know. I'm terrible at this. Language is not my strong suit, and this is my only language. Like I should be better at English, and I'm not. It's terrible.
I think it's the French origin.
Okay, because it's the French word.
Fault.
we are. There's this hilarious video of like, what was it? Coming up with past tenses of words. And it's awful in English, but probably comes from because we take so many different other languages' words and adopt them as our own. But like read and read are spelled the same way but pronounced differently. And you have to know what it is out of the context of what you're saying. Like, I don't know. It was crazy. No, the British use it though. Yeah. The proper Englishmen use it. You're gonna cue the music? Okay.
Music, add it to the queue.
Okay. Yeah, you don't put the music in line. You put it in the queue. Okay, I like that. I don't know. Yeah, that's the common word for line. Like every other English-speaking country, they call it a queue. But all right. So let's see if it works. Right. So let's make our. Should we leave? We can just get rid of all these then, right? Let's do our deck here. So this, like, the UE is silent, even the U, even though there's an E here, the Q makes the K sound. I hate it, I'm sorry. I don't know. All right, so we want to add stuff to the front, we want to add stuff to the back, we want to take stuff out from the front, we want to take stuff off from the back, and hopefully not screw it up. All right, sure. How about we just add 10 things? So we'll say for number in range 1 to 10, or 1 to 11, right? We'll give me 1 to 10. We'll take Q dot, how about add back? We'll add the number. Okay, and then how about for number in range, let's go from 0 to -10, right? Stepping by -1. Let's take our Q and add to the front. Add front to the number. So if we add them from 0 and then -1 and -2, if we keep adding them to the front, we should have now -10 to +10, right? If that worked, right? And then we can say while not is empty, my Q dot is empty, print Q dot. Now we want to remove from the front, right? Usually we remove from the front, but we'll see. So this should be able to get us the values here. Hey, Clyde, my friend, thank you so much for subscribing for 6 months in advance. Oh my goodness, you are donating 6 months worth of subscriptions to the Student Scholarship Fund over at the University of Michigan Dearborn College of Engineering and Computer Science. And I think, thanks to you, now we've pushed that over the next $100 mark, and I'll actually get another check from Twitch, and I can donate that. So I do keep a log on the Twitch channel if anyone's curious. I'm happy to show you receipts. Please don't think I'm making extra money off of Twitch because I'm teaching classes. I just think this is better than Zoom. So we should get, right, the -10 to +10, if this worked. Colon, thank you. What's wrong with my syntax? -10 to +10. Looking good so far. So how about we change it then? How about we remove back? Now we should get +10 to -10, the other direction. +10 to -10. Okay, looking okay so far. And I feel pretty good that the rest works in the directions. And cheering, wow, 3,000 bits. Holy cow. Thank you so much, Clyde. So glad to have you along here. That is phenomenal. My friends, we are just increasing that scholarship fund. That is awesome, because college is way too expensive here in the U.S. We are crazy. All right, thanks so much for lurking. Glad to have you. Yeah, I mean, it sort of benefits me as a lecturer. I get paid to teach here. I don't get paid as much as the tenure track profs. Generally, you're supposed to be able to negotiate a contract and all sorts of things, but generally you get the union set floor when you start, because they're like, oh, here's the minimum salary. Thanks. Okay, sure. That's fine. I like doing it. It's fun, and it pays a decent amount for a hobby job, but definitely not like working in the industry, which is weird. Like, how do you recruit good people when you're like, hey, I'll pay you like a third of what you can make out in the industry if you want to teach? So I do it for fun, and I'm hoping to retire out of the industry at some point, and then teach full time. But you have to like pay off your house and stuff to not have payments for things. So we'll get there. We'll get there. All right. Okay. So I think we're pretty good. We could try like taking a couple out and adding a couple more, taking a couple out before we drain the whole queue. Right. So how about we take I'll take like 5 off of each end. We'll say for I don't know. Number in range 5, we'll just take off 5 from the front and 5 from the back. Remove front, remove back. So 5 times we'll take the front and back. So we should get -10, 10, -9, 9, -8, 8, -7, 7, -6, 6. Right? And then we should be left with -5 to +5 when we're done. But now let's go add a couple more numbers then. So let's go, let's say for number in range, let's just add, I don't know what, from 100 to 200. Go add some numbers. And then, let's add you want to add to the back maybe. Make sure the resizing works, right? We'll add some back here. So then we should jump. We should get that, all the values here, right? 10, 10, 9, 9, 8, 8, 7, 6, 6. And then when we are we're removing from the back. We added 199 to 100, right? 199 down to 100. And then what was left was 5 to -5. Looks like that was okay. Right? Should we add some more to the front? Or do you think this is okay? I feel like it's working pretty well. Again, in terms of testing things, right? We'd want to test that every line of code would run in a unit test. So anytime we have an if block, right, we want to make sure that, okay, at some point we're going to resize smaller. At some point, the back wraps back around to the front. So we haven't tested that. We should probably make sure that works, right? So if we add a bunch of things, so we start with size 10, and if I go add 5 things, take 5 things out, add 10, or add like 6 things that should wrap back around, right? And then I should start taking back from the back to make sure it unwraps, right? I don't think we've done that. So let's, I don't know, should we leave these ones? We can change these ones. So we'll add the 10, we don't even want to fill. Let's just add like 5 things, 6 things here. Adding to the back, and then we'll go take off a couple things and add a couple more things. So then for number in range, let's just take off like 4 values. We'll take print u.remove. How about remove front? Right, we want to take from the front. So the back should be out at index 6. Right, we're going to take 4 things out. So we should just have the 5 and 6 left. Then we want to go add a bunch more things. So how about we go now add from, let's say, I don't know, 7 to 12. Let's add those to the back. That should cause it to wrap around. Right? Then we want to go remove some items from the back to make sure that the back will then wrap back around where it's supposed to go. Right? So we can just remove from the back here like that. So we take out 1, 2, 3, 4, right? Removed from the front. We added in 7 through 11, but then we removed from the back. So they should be in the reverse order, right? The 11, 10, 9, 8, 7. Oh, there's no 6. Oh, no, we never added 6. That's right, because we never got to 6 here. So let me range to 7, sorry. Because range 1 to 7 will give me values 1 to 6 now. This will give me values 7 to 11. Okay, good. So we do get the 6. We didn't skip anything. So I feel pretty good I was able to loop back around, do that circular path. So in terms of testing out for code coverage, right, we need every one of these ifs then to make sure they get ran. So at some point the front needs to loop back around. If we start taking off the front and we wrap back around to this direction, we'd have to test that way too. There's tools for this sort of thing out in the industry. Most organizations will probably pay for them, right? Because like testing, making sure your code does what it's supposed to do is important, and important enough that you'll probably pay for those nice tools. We're not going to pay for them, right? Because we're cheap, and it is good practice to eyeball it, like to kind of say, okay, let me think through what's happening. Am I ever getting this to run here, right? Am I ever having this run here or this one run here, right? And then we can design a test that will make sure that one of these runs. Okay, so what do I have to do to make sure that the back hits the length and back gets reset to 0? Right? We should understand our code well enough, understand what's happening behind the scenes to be able to figure out what we need to test to make that happen. And again, don't just print out a bunch of things. This is the poor way of testing, but it's a little faster for us just kind of having fun with it, rather than trying to code it in and make sure that it works. Is that okay? All right, cool. All right, how do you feel about stacks, queues, and Deques? Again, very specialty data structures. They only work for certain situations, right? Otherwise, the Python list just does what we need. But if we are giving the data to someone else to use, and they should not do things other than add to front, or take from the back, or act like a queue or a stack or a DQ, we are able to limit what people can do with how we're storing the data through these sorts of classes. That's one of the big benefits here, right? If you go and start adding things in the middle of my list now, everything else is going to break because I'm tracking indexes separately, and like if you start changing things, and bad things will happen. So the only way we guarantee that it works is if you use the public methods. That's sort of that idea with Python being trusty. You can go and you can poke around those private items, private attributes, but you'll probably break things, right? And then there's no longer going to guarantee it's going to work. So the next project we work on, I know you're not ready yet for the next project, but the next project will be a stacks and queues project. Right, so we did classes, we're working on the recursion project now, and then we're going to do a stacks and queues project. And then the next topic next week is linked lists. The fourth project will be on linked lists. It's a little weird. Everything's kind of loaded into the front half, but we're going to have more fun in the second half as we go, because we don't need to go as deep into these topics. If you do go further on to algorithms analysis, data structures and algorithms analysis, you'll do trees. We'll look at these at a kind of a high level of doing them, and then we'll have time to do more fun things. So the goal then, right, our recursion project is going to be due next week, right? And we're not going to assign a new project until after spring break, because I want you to actually have a spring break. That's not okay? So then we'll come back, we'll do the 2 more projects, and we'll assign the final project this last week. Does that put us out? Yeah, so 2 weeks for the third project, 2 weeks for the fourth project, assign the final project. We'll have all of April to work on that final project. Because again, that does make up the majority of your grade here, or at least as much as the individual ones combined for that. And then next week, I'll give you last year's midterm, so you can review, practice, look for those sort of questions. I'll give it to you on Tuesday, and we'll talk about it on Thursday. If you have any questions, want to go over any of the long answer style questions. Untimed, you'll have all week to do it, including the lab time. I wasn't planning on doing a lab that week. We'll do our linked list lab the Tuesday after spring recess. So on 3/8, we'll actually do the lab for linked lists. So be a bit of a gap there, but that way you've got the entire lab time, both lecture times to sit and work on this, and that's all you have. And hopefully then you actually get, it's not even spring, it's March in Michigan. Should not call it spring, but it's listed as spring recess on the calendar. I don't know why.
I think midwinter, that's actually best.
Yeah, it's midwinter for sure. I mean, hopefully near the tail end of winter, because like winter ends March 21st, but it's still relatively cold in Michigan, so it's what it is. All right, so that's what we've got going on. Any questions about the project? I think we looked at like a sample 2D list last session, right, on Tuesday. This is what one might look like. So when you're doing the unit test, you can set up a maze like that and say, okay, the shortest path should be this. did I get that shortest path back out? You don't need to test all sorts of other things behind the scenes. Just give it a maze where you know what the shortest path is, make sure it works. You probably want to test other interesting conditions as well. If I don't think it's in here as a requirement, but if it doesn't find a solution, you might want to have some default value, like a -1 or something, or like a 10,000, I don't know, some value, like if it is not solvable, you could do something. Because we could generate random mazes pretty easily with a 2D list, right? Just generate a bunch of random numbers. On a 1 and 2, it's a wall. On a 3 and 4, it's open. Sure, and I can put the start anywhere and the end anywhere. It's like, when my kids get bored, I feed Python a random maze generator and say, hey, make me a bunch of random mazes size X by X, and then I can print them out. And like, hey, solve some mazes, kid. They actually thought it was super cool that like I could do that. And like, hey, pick the size, and like made it prompt, hey, what size maze do you want? And like they were able to pick their own maze sizes and stuff. But it sort of lost the novelty after a while. But that's so like you could say, if this maze is solvable, good. If it's not solvable, then let's not print this one. So you got some options. But again, just the 10 points here. Most of it comes from the backtracking recursion. So please don't find a solution online and hand it to me. It's no good. And most of them don't use backtracking because, well, honestly, it's not the best solution. I like it, and it's a great illustration of backtracking and using this style of recursion here. There are much more efficient ways of solving mazes. Go take an AI class. Like that, for some reason, that's a really good pathfinding. Is like an intro to AI sort of. Well, let's teach a computer to think and do it efficiently, sort of problem, which is fun. If you can find the shortest points, and then testing it as well. So your maze should probably go find a start and end location, not just assume it's top corner and bottom corner, because those are really boring mazes, right? That sound okay? Awesome. Cool, so that's all I got today. We got a little bit of extra time then, and we can go from there. So, oh, the due date, right? The 17th, so in 1 week. So next Thursday then, I'll go over the solution to this as well. Okay? Awesome. Well, I'll see you folks on Tuesday then for lab. We've already built the queues and Deques and stacks. So the lab will be using them to solve problems. Like the actual building it itself is not all that interesting, and honestly, it's in your textbook. Like you can just go copy out of the textbook how to build it. I don't like copying out of the textbook, or even like, hey, here's a done one. Let's just look at the code. I find that terribly dull. So hopefully it was more interesting to build it from scratch. But we've got that. So we'll use them to solve certain problems and look at performance and, you know, figure out which one's going to be good for what, that sort of thing. Okay? All right, folks online, take care. I'll see you on Tuesday then.